We'll be starting in another 2 minutes.
Each and every Indian was full of pride. This was a milestone in not just our journey of science and technology, but also innovation. To encourage this kind of culture of creativity, MHRD aims to nurture young minds of India at their early stage. MHRD Innovation Cell is a step towards that giant leap. The cell aims to promote innovation at the institutional level.
Sanil Kumar sir?
Hello, sir. Can you hear me? Hello.
Yeah, yes sir, yes sir.
Okay.
We'll have a formal introduction and we'll start, sir. Just a second.
Oh, sure. No problem, sir. Take your time.
Pavitra?
Sir.
Yeah.
Good morning to each one of you present today. It is a moment of extreme pleasure to welcome the guests who are present here to attend this workshop. On behalf of the Puducherry Technological University, allied with Institution Innovation Council and Innovation Entrepreneurship Development Cell, jointly organizes the workshop on prototyping. I offer my regards to the faculty members and the students who are joining. Now, I call upon Dr. B. Hemakumar, convener of IIC, to welcome the chief guest.
Okay. So first of all, it's a very great morning. I take this opportunity to welcome you all for this Institute Innovation Cell meeting. Okay, webinar on prototyping. Okay, we all know what is the importance of prototyping. So whenever we come out with a lot of ideas, okay, so these ideas have to be we have many ideas, but how will these ideas be validated? These ideas can be validated only with the real customer experience. But to get the real customer experience, we need to give the customers a real kind of a model or something. So that model is called as a prototype. Okay, so the prototyping is such a very important one. Okay, so here we have with us today expert Dr. Sendil Kumaran sir from IITDM Kanjipuram. Okay, so he's in spite of his busy schedule, he accepted our invitation to share his thoughts about prototyping. Okay, I take this opportunity to welcome Sendil Kumar sir and all the students as well as participants who are registered for this program. So thank you one and all. Pavitra?
Thank you, sir. Now, I welcome Dr. K. Sendil Kumaran, sir, to take over the session.
Thank you for that introduction. First of all, let me share my screen. Okay.
Excuse me, sir. Before you actually, I wanted to give a brief intro about Sendil Kumar sir. Sendil Kumar sir is currently the assistant professor in Indian Institute of Information Technology Design and Manufacturing, Kanjipuram. He is also the head of Center for Smart Manufacturing at IITDM Kanjipuram. He obtained his doctorate in additive manufacturing in the Mechanical Engineering Department of IIT Delhi. He previously worked as a great guest researcher in the Systems Integration Division of National Institute of Standards and Technology, USA. His research interests are in additive and sustainable manufacturing. He is an associate editor of ASTM Journal on Smart and Sustainable Manufacturing. He is a member of ASME, SME, SAE, and IEEE. He is also a member of IFIG WGS.7, Developing Smart Manufacturing Technologies. He has been nominated for the prestigious in-residence program for Inspired Teachers at Rashtrapati Bhavan during 2016. He has more than 30 international publications in peer-reviewed journals and conferences. He is also a regular speaker at various design and manufacturing workshops and events on design and manufacturing. He has taught more than 10 courses in design and manufacturing and maintains an online portal called manufacturingportal.in for blended learning in design and manufacturing education. As part of the outreach activities, he is also the coordinator for Teaching Learning Center at IITDM Kanjipuram, funded by MHRD India, which develops extremely affordable digital fabrication techniques for colleges, polytechnics, and schools for STEM. He is also in charge of the design for additive manufacturing lab at IITDM Kanjipuram, funded by MHRD India. Thank you, sir. Thank you for accepting our invitation. We feel extremely happy to invite you on behalf of Puducherry Technological Universities. You can take over, sir. Thank you.
Okay. Thanks for that introduction. Hope my screen is visible.
Yes, sir. Yes, sir.
Okay, and also I am audible clearly to everyone.
Perfect, sir.
Okay, thank you. Thanks for the confirmation.
Yes.
Yeah, I think before I start my session today, I must tell all of the participants here They may be students or a faculty, or maybe from practitioners, maybe from the startup. Maybe you are a budding entrepreneur, or maybe you are, administrators, educational administrators. So the idea of design, thinking, right? So the philosophy behind design thinking is expressed in two ways. One is think in design, or design in thinking. Okay, so how to design your thinking in a way so that you can creatively solve any problem, or how to basically think in design, right? So, or how to basically design your thinking. So both are important elements of design thinking. I think you all knew about the various steps involved in design thinking, starting from empathy and then all the way going up to testing. And somewhere in between, there is something called prototyping. Okay. So what is prototyping, and what it takes to basically build a prototype? And what are the different types of prototypes, and how it is domain specific, and the tools and techniques involved in prototyping. And those issues are what I'm going to concentrate today. Okay, so to be a designer, right? So the first thing that someone has to do is ideate. Okay, so he has to have idea. That idea needs to basically validate. You need to get that idea validated. So many a times we have seen in the innovation cycle, you make a PowerPoint prototype, right? So you make a PowerPoint presentation about that particular idea, and convey that idea, and then you get some money, and then create a POC, the proof of concept, and then get venture capitalists to fund your idea, and then you commit the design after a few iterations, and then you launch the product or commercialize the product. Okay, so the journey that entrepreneur goes through, he might encounter this word prototype many times. And managing an innovation or the innovation cycle, where you have to fail fast, right? So the prototyping helps you to fail fast. You could achieve your prototyping failures so fast so that you can reach the solution very quickly. Okay, so why I should talk about fail in the first place? Okay, so the prototypes are made to fail. So the prototypes are only made with an aim not to succeed but to fail, so that you can refine your idea. So the idea is good as long it works. So, right. So, and to make it work, you need a prototype. Right. So these are very important aspects of prototype. Okay. So let me just use my slides a bit. Okay. So now what we are trying to basically understand here, trying to basically help people to realize their idea. So you need to create a working prototype. You need to create a working. So here you can see that people are trying to basically draw a picture on the backdrop, right? So this is what we call as co-creation. Different people trying to basically give different elements to the idea. So you can approach the idea from multiple directions. If it's a software product, if it's a hardware product, or if it's you're designing some services. So user experience can only be captured if you have a tangible prototype. So when you experience, so you need to basically, when you want to do the persona analysis, you want to basically do design synthesis, right? So, and in the analysis, you need a physical prototype to test your idea, right? So let me just see what are the what is different kinds of prototype. Okay, so what is a prototype? How do you construct one? Right. So what are the different kinds of prototyping? And what is the granularity with which you build your product? So the resolution, whether it is granular in vertical, or whether it is just a shallow, but you build a horizontal prototype. And finally, you build the product, construct the product. Right. So if you look at this particular innovation cycle, right? So what we talk about here in the innovation cycle, say a prototype has multiple things. We always say this: an idea conveyed through words, an idea conveyed through a diagram, or an idea conveyed through a sequence of diagrams, or an idea conveyed through a working prototype. So everyone has different levels of interaction, different levels of synthesis, different levels of exposure. Okay, so let me just give you an idea about, that people say that one image is equal to 1,000 words, and one 3D model is equal to 1,000 images, and one physical prototype is equal to 1,000 models, 3D models. So anything tangible which you can give it to a user, the user can actually experience it in a much better way than expressing that idea. Okay. So a working prototype is very essential in the design process. So after you commit the design, you still need working prototypes to do many other aspects in the construction aspects too. Okay, so now what is a prototype? So let me just see some examples of what is a prototype here. So for some user, to evaluate a design, okay, and the design is more interactive in nature, right? So and they have to have an interactive version of that product or idea, which is called prototyping. Okay. So normally, there are multiple fields. You have softwares, you have software, you have hardware, you have services, right? So built as a software, services built as a hardware. So wherever you find a user coming and interacting with your product, so that interaction or the design of that interaction is what normally is called prototyping. Okay. And in engineering terms, because it's a technical university, in engineering, prototyping meaning building the actual model of a prototype. So we call sometimes a near net prototype where it looks like actually the physical product. So it's a very high fidelity prototype. So you use the same amount of material, you use the same shapes, same size. So to the actuals. So it's a near net prototype, a high fidelity prototype. So let's say a material you want to design in copper, you use the same copper. So if you use simple cardboard, a styrofoam, or simple sheets of paper, or a 3D model, or a virtual reality, we call them as the low resolution prototypes. Okay, so you can build a miniature car, a model of a building, right? So you must have seen people approving designs based on a miniaturized model, right? So, right. Whereas in prototyping, when you talk about interaction, is about sketches, right? So you have a series of sketches. Sometimes just a simple PowerPoint slideshow, which shows how the user interface look like, or maybe a video that simulates the things, or it could be just a simple lump of wood, or to represent a computer, or maybe a styrofoam, or a sheet metal, right? So a cardboard, or you can say a software which doesn't actually have the built-in engines in it, but probably just the a limited functionality. Just like when you go to a mobile phone, you want to buy a phone, they will sometimes they hand over a real phone, sometimes they hand over a mock-up. So that they call this is a dummy, right? So it's actually a prototype. So it's not a working prototype, but it's like how this you can understand the form, a little bit of functionality and little bit of fit, how it fits in your hand. So how it fits in your pocket, how it fits in your wallet and stuff like that. So, in your purse. So you can see a form and fit can be evaluated, but a function is not really. So if you want to make a fully functional prototype, that means it has to do all the functions that the product should do. So that becomes a fully functional prototype. So for it to function fully. So yeah, so I think you get a fairly good idea to, as of now about what prototyping is all about, right? So okay, so so what is the reason for someone to do the prototype? So what is the need? Why somebody needs to do the prototyping? Okay, so let me just give you some examples of you know. So what is the need? So it allows the people to stakeholders to interact, uh, to gain some experience, right? So in a realistic environment, and you have identified some set of user persona and see whether you can actually cater to their needs, right? So that is what we call as the evaluation. So to get a critical feedback about the product, so how they feel about the product, right? And sometimes you can use it to build consensus among your team members. Probably you have a set of requirements that you have captured, user requirements you have captured in the empathy and all those aspects, and then you have a very vague requirement. You want to translate that requirement into concrete requirements. So you can use prototype as a means to build consensus among communication among members. It not just among your team, but also when I say team, in Indian terms, it's in hierarchy. Like you have a boss, you have a manager. So in Western world, the manager is also part of the team, but here you have a team and then you have a boss who approves it. So in the hierarchy, you can also communicate. So a non-technical person, you can build a prototype and make that non-technical person to communicate, right? And you can also validate, right? So so you had a hypothesis, you had a really cool idea, whether that idea really works in the real environment, right? So you want to test whether that idea functions or it works. So you can give a users a tool to give their feedback, right? So to test out in design thinking, if you remember, we have the technical feasibility, the economic viability, and social desirability. All are important elements of a design, good design, right? So you also has to have other aspects of it, right? So let's say is judiciously tenable, not just socially desirable. Uh, Acceptable by different communities, or maybe certifiable by an agency or by eco label, right? So things like that. So our requirements have not just in terms of meeting just the technical requirements, but also regulatory standards like RoHS, REACH. So you want to see whether the prototype has less impact on the environment. Will it be eligible to receive the 5-star ratings and other eco labels? So you can just that is external stakeholders perception. So you can validate your design with an external stakeholders. Okay, so the organizers, can you please mute all the other participants for
Yes, sir. Thanks.
a better experience? Okay, so thank you. If they want to speak, they can always raise their hands, and we can have interactions. Okay, thank you.
Yes, sir.
In between. Right. So when we want to choose between multiple designs, right? So alternatives. That's another example, right? So, okay. So I think I gave a fairly good idea of what a function of a prototype. So I think this session is in 1 hour duration. So I may take another 10-15 minutes to explain the prototype and then move on to what we do and how we can actually help you out. And I'll show some of the important things about where do you create this prototype. So how do you create this prototype and how culturally sensitive these prototypes are. And maybe I'll just give you some overview about the makerspace that we have, which is the country's largest makerspace. We have the 18,000 square feet makerspace. I'll give a little bit of overview about what we do and stuff. Okay. So maybe I'll reserve it for the last 10 to 15 minutes. Right. So, okay. So I think you got some idea about why to do the prototyping. Okay. So what are the things that you are looking for? What to prototype for? Okay. So first thing is technical issues, right? So when you have an idea, I have one of my student. He talked about carrying internet in his pocket. He told that I can put internet into my pocket so that I can carry it to regions where there is no internet. The idea is good. It's a very noble cause, but yes, it is possible right now. Internet is available in your mobile phones. It's pocket friendly. Means like it's very inexpensive. Also, the size is really low. It's portable, right? But the issues is connectivity. Where to connect, how to connect. So you need a connectivity issues in very remote areas. When you go into wilderness, will you be still able to connect? So idea is good. So there is a solution today. You can use satellites, satellite communications. Maybe then how to connect to the grid. So you don't have a grid. So probably you can use solar cells to harvest the sun energy. So the solution is there, and people have now found a solution for those kinds of problem. The idea was there, and the solution is also there to connect between that idea to the solution, right? So you need to freeze the technical issues. Right? So how do I really carry my internet to remotest part of the corners of the world? It's a very challenging problem, right? So just that is one. Technical issues. There may be issues resolved that needs to be resolved. That can be only resolved through building a prototype. Right? And sometimes people also prototype the workflow or the task design. Let me say you want to design a ticketing system. You want to basically design a ticketing system, maybe a book my show type of thing. You want to book a ticket to KGF 2 or a Beast movies. So you are eliminating that long queues that you need to stand. So the problem you have identified, but then you have to design the workflows, how the user interacts, what information that the user needs to book a ticket, and what will be the workflow and what are the tasks, and maybe there is a financial flow, there is an information flow, there is a flow of sometimes a product, right? So how to basically model these flows, how to design those tasks, how the user experience and design would be on that app, right? So that is typically the software prototyping, right? So you can identify the design elements, the colors, the textures, the visuals, the symbols, the paradigms, the metaphors. So all those things you can prototype. Okay. So a very good design of an app is something where people don't have to search. It's more intuitive. It's a natural flow, right? So you can design, you can prototype those elements. You can also design screen layouts. You have a very fixed piece of real estate on a mobile screen, and you have to place certain type of icons for interaction. So where to place them and how to read the information display, right? So, and there are very difficult and controversial and critical areas that also has to prototype. Sometimes, going ahead with removing all the text and only using symbols. Nowadays, if you see most of the Android apps, they have no written element. So earlier they used to have translators. So 60 countries, they will have their own app, Japanese text, and then Chinese Mandarin, and then You have the Deutsch, the Germans, the Espanol, the Spanish, and stuff, right? So you have to write translations for the tooltips and tool menus and stuff. So now, if you write one app with symbols, right, so you don't have to redesign that app for localization, right? So one global app, it works for everybody, right? So but it's a very simple piece of element, but still sometimes people have to remember the symbols. It's very difficult. It has to be intuitive. Like in this case, for example, I put us so we put a spanner for technical, for a flow, for a gear, and layout for a screen, and then difficult. So symbolically, you can actually, without using any text below, you could even tell about the issues that you can just, it's like you can just see how the visual elements itself conveys the meaning of what you intend to convey and stuff, right? Okay. So what are the two? I think we have seen two different types of prototyping. One is the low fidelity, and another one is the high fidelity prototyping. Okay. So what is a low fidelity prototyping? So like low fidelity is like, it's a gross approximation. It's of a final product. It's like it doesn't look actually like a final product, but it sometimes, you use a cardboard, you use a styrofoam, maybe use a simple piece of wood, or even in automotive, in other disciplines, they use a clay. So they like clays. The stylists work with clays, right? So to create the first look and feel of the prototype. So that is a low fidelity prototype, right? So here, one of the key differentiator between lo-fi and hi-fi is that the material, the use of choice of material, they are very different from the intended final version. Something like you just simply use a paper or a cardboard, then an electronic screen or a metal, right? So things like that, right? So which fits in your palm, right? So which fits in your idea, like so, and mostly used in the very early stage. As you progress, as you build the first ugly prototype, and then go to the proof of concept, and then the functional prototype. So the granularity, the details, and the level of details gets added. So you get the actual colors, you get the actual materials, you get the actual texture. So you get the actual footprints of the product in a real one-to-one scale sometime, right? And so the reason for going for this is very cheap, because you never knew that this decision is going to be committed. So you have too many alternates to evaluate. So probably the low cost way is to make it in materials which are low cost, right? So, and it was never intended to be, into the final system. So it's a space, the exploration of the idea space, right? So that's more important for a low fidelity prototype. Okay, so coming from this, what are the good examples of a low fidelity prototyping, right? So you can build a storyboard, you can do sketching, you can do index cards, or you can do the Wizard of Oz, right? So the storyboards, actually they come from the media, right? So probably you must have heard about the storyboards come from the visual media, right? So the movie making and the animations, the game design. So they use a lot of these storyboards to capture scene by scene the actors' roles and their positions, and the dialogues and the look and feel of the environment and stuff, right? So you can do that same storyboard stuff for designing your apps, designing your product, designing your user interaction with the product, right? So that's a one example of a low fidelity prototyping, or it could be simple sketching. So you can do a industrial design sketching. You can use index cards and Wizards of Oz and stuff, right? So this is the basic examples of a low fidelity prototyping. Storyboard is where, originally from the film industry, right? So here users get an idea of a scene, and so it's like, when users are going to have an interaction, so it specifies certain snapshots of the interface, right? So it is just nothing but a series of sketches drawn neatly, right? So, and how a user actually uses it, right? So, and you have multiple user scenarios, so you can see how you have a written scenario, how a user interacts with the system, how somebody brings more details into the scenario, and it's like you actively take the role of the user and then try to basically experience yourself with the scenario and then identify, the problem areas, the critical, the contentious issues in design. Okay, so sketching, as I said, you can use symbols. So there is no sketching. People think that, I need to have really good drawing skills, right? So without that, I may not be able to create sketches. So you can use the simple symbols, not real world objects. You can use metaphors for a file. You can use metaphors for interaction, for activities, as well as for the objects, and then try to basically create a scenario, right? So, and you can also, any temporal issues where things happens at a sequence, like a task A, B, C, one after the other in a sequence, you can use flowcharts. And then for functional things, you can use a block diagram. In software, people use UML diagrams, use case diagrams. So UML is a unified modeling language. So now they use systems level modeling language to do the functional block diagram. In electronic, there is MATLAB based Simulink to do the functional design. Reliability, you can use functional components. The functional block diagrams, they are in engineering as well as in conceptual design, right? So even industrial designers uses block diagrams for functional components. So you can use simple sketching to prototype. You can also use index cards. It is something like, you have a one screen, you take multiple screens, multiple cards, and then lay them out on the screen, right? So you can use threads to indicate the connections between them, either in a sequence or maybe form of hyperlink. So this can be used in a web design. So when you are developing a website or an app and stuff like that. Now, coming to the high fidelity prototyping. So this is about where you build a prototype to the actual look and feel, as well as a little bit of functionality there. Now, here you have the choice of material is more like very similar to the one that you would actually use in the final design. So metal means metal, ceramics, plastics, metalloids, semiconductors, composites, right? So maybe you use papers, maybe you use wood. So whatever is the material, maybe concrete. So try to use the same material. So build the same prototype. So this is a little difficult to do. So the previous one was also very difficult. Both are creative process. When somebody sets out to do the prototyping of high fidelity, that's when you have to understand the processes. So there are many processes in high fidelity prototyping. So there is something called as virtual prototype. There is something called as physical prototype. In a virtual prototype, you can use virtual reality, augmented reality, you can use extended reality, mixed reality, hyper reality. So you can use varieties of realities. In the digital mockup that you create, you can have fully immersive experience with all the senses fed, like kinesthetical, visual, oral, tactical, all those senses. You could feed those senses and then create a feedback about the design. So that is the virtual prototyping. So user can navigate through the design, right? So that's what is virtual prototyping is all about. So where you don't use the actual physical prototyping, but it's virtual world, but it actually mimics all the functions. The user can interact with it, either using a complete immersive experience like a cave system, we call them as computer virtual environment, or maybe a handheld with a head-mounted like the Oculus Rift, Microsoft HoloLens, or HTC Vive, and even simple cardboards, right? So with your mobile phone apps and stuff, right? So or you can build a physical prototype by using 3D printing or vacuum casting or hand layering, composite molding, silicone rubber molding, or metal casting, or wood turning like wood machining, or maybe stone, using stone and natural materials like rock. So you can build a physical prototype. You need a shaping techniques to. You need a very economic methods of making only one single piece of product. So that's where is that. So here looks more like a final system in the high fidelity prototype, but it may have a little bit of functionality of the final product, but it's more to I think there are 4 F words, right? So form, fit, function, right? So and fidelity, right? So what is the fidelity of the form? So what is the fidelity of that function? What is the fidelity of that fit you are trying to basically test it for? Uh, you can have systems that actually looks more like the final products. You can also use for a software prototyping, as I said about physical prototyping, a software prototype. You can use development environments. These are some very old techniques right now. You see, there are a lot of techniques, web development tools. You have web prototyping. You have so people normally use this Flash, and those kinds of animation tools to design interactions. Now you can have a lot of web-based prototyping tools which you can use. But sometimes, so there are some drawbacks here. One of the important drawbacks in high fidelity is like misled user expectations. Users may think that they have a full system, but they may not. I'll give one example here. So today, I think more than 3,000 EV startups across the world, and around 16 or 17 of them are billion-dollar companies. They have been already listed into the NASDAQ and world stock markets. They are billion-dollar companies, and some of them also have booked. They have went to the customer with one single prototype. They made one version of a EV, which is working prototype, and then they got interest-free loans from all the customers. And now the hardest part is to commit the design and make multiple parts out of it. So now what happens is like the users who have booked, for example, the Tesla Cybertruck. So launched in 2019, I believe. Right? Still, they are not yet delivered. So that a lot of specs have changed and a lot of expectations have changed. So users had an expectation, and suddenly it's not possible. So building one is much easier. In a physical prototype, when you build one, it's much easier to build. But when you scale up for a real production, when you build it, when you start constructing the product, so it becomes much difficult. Same with the use of softwares. So maybe if you prototype for a one aggregator app, probably you are trying to aggregate some services. Probably we have taxis aggregator, food aggregator. Maybe you are trying to basically aggregate some tuition centers, right? So probably educational aggregator. The idea is like you can make a one single prototype and get money. But when you when you want to scale it up, right? So that's another problem. But still, the user expectation that you have created in the prototype may not translate into real requirements. The user may have greater expectations from the product, but when you scale it up, so it may not work the way. For example, a day before yesterday, there was an overarching app called Tata Neu, which was launched. Right, so users are complaining about their experience with the app. So, like most of the Tata services earlier, there in healthcare, grocery, retail, electronics, and medicine, food, and all those things, it was an overarching aggregator app, but still, it is not well. The prototype was okay, so when it was shown, but in the scale up now, there's a lot of issues, right? So, because the users have a lot of expectations about it, and then they could end up with some experience what they have not envisioned. Right, so these are some advantages and disadvantages of the low fidelity and high fidelity prototypes, right? So the advantages is like low fidelity product, we have a very low development cost. You can evaluate as many designs as possible, but you have very limited capability to test it, right? So the navigational flow limitations are there. And the high fidelity prototypes, it's like fully interactive. It looks and feels like a final product. It clearly defines navigational schemes, but it's very expensive to build. It's very time consuming. And also we have this mother baby syndrome, right? So you cannot tell a mother that her baby is ugly. So the designers, when they design, they put a lot of sentiment into the design. So it's as they begin to show the designs to the users, and the user complain, they say, no, you are not using it properly. Why don't you try this? Why don't you? Because they want to justify what their design is true. Sometimes that's sociological aspects of a design process. So the developers, the software developers, or maybe the hardware prototyping, so they have a trouble of understanding what the users really want, right? So because of their mother baby syndrome is there, right? So it's their own design. They feel it's really difficult to change. It's there with every field. Let's say architect wants beautiful, nice things, and then probably the engineers may feel it different. Industrial designers and engineering designers, maybe a fashion designer and a textile producer, like textile mills. So all these guys, textile engineers, technical engineers, they all have this problem, right? So translating a design into a useful working prototype may create a balance of perspective, right? So people willing to basically accept and iterate. I think you all knew about James Dyson. So there's a Dyson competition also. James Dyson is a British designer who have pioneered the product design. So he made 5,887 prototypes of his vacuum cleaner before he finalized. Maybe in the mall, you must have seen when you are drying your hands, you put your hands through a dryer which has no fans, but it still produces. So you must have seen the fanless blades. So Dyson is James Dyson is a British designer. He also had a EV concept, but he could not. He spent 400 millions on that concept to build EV, but he could not commit the design and go to the production. So yeah. So what I'm saying is like, so people build even 10,000 prototypes before they fail. I think you all know about very well-known examples of Thomas Alva Edison. For the bulb is now being used as a metaphor for idea. So he has to build so many prototypes. He has to fail so many times before he could succeed. He found a way to do sintering of the tungsten filament. So the process he invented through prototyping. Thousands of prototypes he built, and then he failed miserably. His entire lab burned. And someday he found a way to basically make tungsten filament through sintering process. So the process is more important. So I'm going to spend my next 10 minutes on that process. I'm going to switch my slides and tell you about MySpace and give you an introduction about what we do. So which will help your community, technical community. So I'm going to move away from the hardware part and move more towards the software part. Okay, so let me just share my other set of screens. Okay, so hope you are able to see my shared screen. Okay, are you able to see the screen?
Yes, sir.
Okay, so far I gave an introduction about prototyping, right? So I'm going to talk about MySpace. So before I introduce MySpace, the contents of this 10-minute slides are what is the many names of I'm introducing a term called makerspace, right? So what is a makerspace, and what are the types of makerspaces, and what you can do with the makerspace, and what are the engage models that we have, and the facilities and labs that we have, and the impacts that I have created with this makerspace. Okay. So you must have heard about this particular term, Maybe you all might have heard about this words: maker spaces, make labs, maker hoods, hacker space, creative spaces, fab labs, idea lab, innovation lab, tinkering lab, tech shop. So all these things mean something. It's a community operated space, right? So where people with common interests, right, often computers, technology, science, and digital art, they can meet, they can socialize, and they can collaborate. So this is what we call, right? So the major aims of a makerspace is to design, create, and innovate. I think, in fact, that is our motto of IEEE 2, right? So what are the different types of makerspaces that you normally see? You will have school makerspaces. So Atal Innovation Mission has set up Atal Tinkering Labs across the country. So in US, they are also used as STEM labs, right? So for introducing science, technology, engineering, arts, mathematics, and management into the school, right? So it's a school makerspace, right? So every school has a makerspace. They have a 3D printers, 3D scanners, CNC routers, and then art stations, and then PCB making, electronic assembly, and then little bit of metalworking, right? So second is what you see here in public funded in libraries. You walk into any decent library in US or in European or in some Asia Pacific countries, you would see it's a not for profit. People can use 3D print something, they can make something, they can prototype some ideas what they have. It's a publicly funded not for profit makerspace. Okay, so you also have innovation labs like startup mission. So incubation centers like the one that the countries have built. So you have incubation centers, startup accelerators, innovation hubs. So here, people with mission driven, they want to basically have an idea, and then they want to commercialize it. So they apply they want to make it. This is one of the incubation center that we have in our institute. So we have a pre-incubation area. We also have graduated more than 25 companies, and more than 12 companies are under incubation. And you have a profit-based maker spaces, like you have a really good idea and you want to get a Nidhi Prayas fund, and you got a fund also. You pitch the idea to the government, and then government gave you money. But the moment the money is in your hand, but you don't know how to spend that money to create the first proof of concept, you can go to these commercial maker spaces. It's like a gym, you go to a gym, you pay a premium, you pay a monthly subscription fee, and then you build the muscles, right? So here you can actually pay a premium every month, a membership fee, and then kind of use these facilities to build your product, right? So, and the one that I'm showing towards the end, this is my academic makerspace, like the one that you see in Stanford and Caltech and all other places where there was a lot of innovation. So this is my own makerspace. I have a 18,000 square feet, the country's largest makerspace. It's called TLC, Teaching Learning Center. You can visit them at tlc.iittdm.ac.in. So this TLC houses metalworking, woodworking, composites, polymers, like compression molding. You have vacuum molding, and then you have layup centers, and then silicone molding. You have all sorts of plastics and composites, 3D printers, 3D scanners, electronic workspace, robotic shop, mechatronic shop, low-cost automation labs, physical prototyping lab, virtual prototyping lab. We have AR, VR headsets, immersive rooms to create physical and virtual prototypes. We have extended reality setup. We have 3 fully fledged studios to create video prototypes. In software prototypes, we have Visual Design Studio to create a software prototype. So that is the 18,000 square feet makerspace to create any prototype that you want. Okay, so what you can do with the makerspace, for example, as a student, many times you have a really good idea, but you are not good with the hands-on. So to build a prototype, you may have to start with some kits, right? So when you can visit our place, or maybe your own university, so you can take some of these kits to develop your hands-on skills to build a prototype. So when you come to our place, what we do is we ask you to build your first prototype. You can build your first mobile robot. You can build your first drone. You can build your first smart product, right? So your product, like you can see they used woods and aluminum and 3D printed parts together with an emergency button. So this is like for blind people, it's assistive technology, right? So it's a drone. Here you can see school kids building a mobile robot in our place. So, and they are teleoperating it, right? So you can build these things. These are some kits. And you can build a EV. So this is the electric vehicle that is built in our university campus. So we have a kit so that people can come and start building an electric vehicle and make it more autonomous. So when you have a very low prototyping skills, right? So to gain confidence to work with the prototype, to build a prototype, so you need to basically use these tools. You may have already existing mobile robot kit. You just want to kind of start. So we give the mobile robots for the school kids, drone for the schools, and smart products and electric vehicle for the college students. And they come, so they get kind of very comfortable by learning by doing, or the prototype phase of it, right? So that's the thing, right? So you can also prepare for competitions, like maybe you don't have your own idea, but you are trying to solve someone else's idea, like Smart India Hackathon. Somebody defined a problem statement for you, but you are trying to basically create IP in that direction. So you can prepare for competitions like that, Smart India Hackathon, or maybe you have your own club. You need to use these maker spaces to create. For example, we have our AEV society. We build underwater robotics in our place. We have a test rig for underwater robotics. We have a competition. We have one Singapore second prize. Yesterday, the Mars Rover Society won the second prize all over the world, like SEI Club, and also we have the Mars Rover Society and Flipkart challenges. These are some examples of autonomous robotic systems for warehouse robotics, Amazon warehouse robotic systems and things. So we can prepare for competitions. So this is one where IIITM students have stood second in the entire world, right? So our makerspace supports that, right? So the student community comes in, and then we allow them to use our space to build their prototypes, right? So what are the engage models that we provide? You can use our single machines and materials. You can come and use our milling machines like HOS machines, Shopbot routers. You can use our wood turning lathes. Like you can use our wood cutting routers. You can use the PCB printing machines, electronic workstations. And sometimes if you are building a product, you can have a longer engagement model like internships. Or in fact, you will be surprised that many people have come to our place and they built their own makerspace. So we provide a facility to build even your own makerspace. It's a mother makerspace which makes another makerspace. You can build a 3D printer. You can build a CNC router to build your own makerspace, right? So to begin, you can start your own YouTube channel, EdTech, like Byju's, today their revenues are 97,000 crores, whereas the higher education spending in this country is only 27,000. Sorry, the school education is 27,000 rupees. So you can start your own YouTube channel, educational content creation using videos, animations, extended reality. If you are a tech startup, you can come. We have a DIY studio. With one single click, you can go for a very full-fledged recording. We have acoustically shielded 1.5 crore studio with all 18 different cameras, right? So you can do that. And also we run a lot of social innovation programs with school students, and a lot of things you can do. So this is our makerspace. We have a digital fabrication lab, mechanical workshop, CNC machines, physical prototyping, virtual prototyping, mechatronics, electronics, fab labs, smart products. So this all comes under my entity. And this is not part of our teaching labs. And these labs are only for the external stakeholders, like college students from other colleges. They come here and use it. So we have a separate design studio, separate innovation lab for our own students, but this is for external students. We have a design studio and then MOOC recording studio with state-of-the-art recording, and then immersive classroom recording studio for EdTech startups, and visual design studio to build your visual user experience designs and stuff. So this is the snapshot. So this is the AR, VR stuff. This is the HOS milling machine. And we have other 3D printers here. And then we have libraries to, do and design spaces, right? So these are some of the facilities that we have, like HOS VFW machine, abrasive water jet cuttings, and Shopbot Buddy routers in the first floor. So we have 5 floors. It's a 18,000 square feet facility. So you can see our own machines. These machines are built by us. So you can also build your own machine. So our makerspace are built by our own equipments, right? So you can build your own equipment and you can build your own makerspace. This is the prototyping lab. So you have scanners and printers, AR, VR studio, and mechatronics, and robotics and mobile robotics lab, electronics prototyping for PCB designs. You may use breadboards and stuff for your ugly prototype, your cardboards and stuff. Then you can miniaturize it for wearable computing. We have a wearable computing lab too. So virtual prototyping lab and stuff. So we have all those. So then we have the smart product design lab where you have IoT based products and stuff. So engineering. So we have more than 50 Raspberry Pis and Intel Edison boards, Z10i cameras for the automatic navigation, lidar sensors, and we have all kinds of sensors. Like we have more than I think 3070 different classes of sensors, right? So which you can work there. So we also have a MOOC studio, so which is like a full-fledged studio there, an immersive classroom recording studio, and a small pantry to chill, and then a visual design studio there. So this is the screen. So what we do actually, we also conduct programs. We do the faculty induction program, right? So like we have the faculty induction training programs and innovative design manufacturing workshops. And then we also do outreach programs. So we carry our equipments in a bag, 3D printers, to teach you how to basically get yourself comfortable with the prototyping, right? So like, for example, these are a set of college students who came from Coimbatore. So they built the machinery in a week. So a faculty with a set of really good students comes there. They build their own makerspace. They build their own idea labs. So you can build your own idea lab and you can operate it. As I said, it's a makerspace is a community operated space, right? So you have to operate it. The students build their own machines. They operate it. So it's relatively inexpensive. Like, for example, we have a 5-in-1 CNC router that you can build for 1 lakh. It does 5 different functions, like, vinyl cutters, right? So you have, CNC routers. Then you have PCB, everything in one machine. So it's like, it comes for, something like 50,000 rupees for a plastic PVC based frame or a aluminum frame. You can spend 1 lakh and get 5 machines in one. So you can build that here. So we promote the DIY projects. We also do the affordable EdTech development missions. This is a Bangalore based college. We also do reach out to schools to foster innovation. So we have set up InnoSteam labs along with some SRF foundations. So it's a CSR wing of many companies, right? So, and the impact story is like, so we all know that you must have read the Ikigai book, right? So the Ikigai tells about 4 different quadrants, like what you are good at, and what you love doing, and then what you can be paid for, and then what the world really wants. So if you find a sweet spot among them, then that is what your entrepreneur's journey or passion is. You are passionate about one problem and you want to take that problem for your entire life, right? So that problem is what the world really wants to solve. And these are the problems the world really wants to solve, right? So where the money is, so for climate and gender inequality, quality education, the EdTech, the digital university concepts, and also clean water and sanitation. So if your ideas fits into any one of this, the problem, so already the Ikigai, right? So what in your entrepreneurial journey, right? So you want to carry that problem, right? So you don't want to kind of do a 1 semester project and shelve it and move to the other project, or maybe switch companies and you get a pay grade or pay hike, right? So you have to be passionate about that problem and take that problem and then work on that problem for your entire life. You will taste success. So people have built enterprises, the huge MNCs, they are built through passion of solving only one single problem. It could be a strategic problem for countries' peace and stability and defense and security, or it could be an industrial problem to increase the competitiveness of the industry, like Smart India Hackathon problem that you see, or it could be a social innovation problem, addressing the bottom of the pyramid, addressing the needs of the commoner, addressing the needs of the kin and kith, your neighborhood, your own people, right? So I with that end note, I want to just end my lecture here with some of the outreach that we have done. We have done a lot of service learning with school students. We are mentoring more than I would say 50 Atal Tinkering Labs. So we reach out to them, we give them training, we service their equipments, we give them training on we give them curriculum, how to basically innovate. So last week, MHRD, or the Ministry of Education, has released the innovation policy for schools, and we are actively helping to achieve the goals of that. So we also bring school kids through InnoStream program, through SRF Foundation. We also have international student exchange program. Many Japanese students come here and then they go to schools to teach about innovations and prototyping and stuff. And we also have a active collaboration with EDAI, so the Entrepreneurship Development Institute, Innovation Institutes, right? So And we also go to the school exhibition, showcase the prototyping tools that we have developed. And we also go to many schools and showcase what prototyping, how they can translate their idea into a prototype and then gain useful insights about their ideas, right? So, and we also do service learning. Sometimes we also work with women entrepreneurs, and we also bring parents to our makerspace. In fact, our makerspace has been visited by more than 27,000 students so far. And they come as an industrialist. They come in buses. They spend a half day. I give them an orientation about what is prototyping is all about, and then take them to a tour. And it's free. You can just bring your students. You can, if you are a faculty, and then we can arrange a guided tour of our makerspace. So thank you all. I think if you have any questions, I'll be happy to answer. And here is my mail ID if you want to write to me. So you can just write to me here. Thank you.
Thank you very much, sir. It was simply superb. And we actually wish to reach you directly. We want to meet there. We'll bring our students, sir.
I'll be happy to engage with your students and
Yes,
help them through the journey of entrepreneurship and
Yes, sir.
make them feel at ease when they want to make a prototype. Okay.
Yes, great, sir. Thank you. Students, if you have any doubts, participants, you can ask, sir. You can also put it in the chat window. Okay, Pavitra.
It is my privilege to have been asked to propose a vote of thanks on the occasion of this event. I, Pavitra, on behalf of Puducherry Technological University and IIC, extend very hearty gratitude to the speaker for gracing your crucial work and sharing with us your opinion today. It has been a pleasure to host all the participants of the event. The participants were very enthusiastic, and I'm thankful for them coming here to attend this event. I wish this event enlightens us all and provides us with approaches to deal with the problems of tomorrow. I would like to thank our distinguished speaker, Dr. K. Senthilkumaran sir, for making an excellent presentation and making this workshop a very meaningful and interesting. We have been fortunate to have the eminent person from industry and utility work in the area of power system. I'm sure that the participants are benefited by coming here. I take this opportunity to extend my sincere thanks to our Honorable Vice Chancellor, Dr. S. Mohan, for giving us the permission to conduct this event. And I also thank Dr. R. Sundaramurthy, Executive Director of AIC PECR, and Mr. Vishnu Vardhan, Chief Executive Officer of AIC PECR, for their support over the conduction of the event. And Mr. Kameshwaran sir, Incubating Manager from AIC PECR, for fixing the chief guest of this event, and our IIC convener, Dr. B. Hemakumar, for taking this initiative to conduct this workshop. Finally, I thank the wonderful students who have turned up in such great numbers, not only from our department, rather also from other departments of the institution. Thank you so much for your cooperation. Once again, I thank all for the cordial cooperation. Thank you.
Thank you, sir. Thank you very much.
Thank you all. Thank you for your patient listening. You can write to me if you are afraid of asking questions here. Please write to my mail ID. You might have taken out that from my
Yes, sir.
last slide. So thank you. Thank you.
Thank you very much.